Hey there, and welcome to the Coding Ikigai. I'm Harsh, a software engineer at Oracle, and I am on a mission to help you find your niche, your Ikigai in the world of programming. You're about to dive into the Core Java Programming series, a completely free, in depth guide designed to know everything there is about the Java programming language and to get you industry ready. So let's get started. This is episode 3, part 1, Order of the Operators, a guide to expressions and their evaluation using the rules of precedence and associativity in Java. And you are watching a series of such episodes to gain a deeper understanding of the Java programming language. Based on the feedbacks to keep the videos concise, we have divided episode 3 into multiple parts to ensure that the content is more manageable and not overwhelming to cover in a single session. Having said that, I have broken down this video into multiple chapters, so if you're already familiar with the topic, go ahead and jump to the next one. If you missed any of the previous episodes, you can check out the complete Core Java playlist linked in the description down below for a detailed understanding. CCC Nagini. And of course, if you're not in the mood to scroll through the playlist again, fear not. We have introduced a brand new segment, a 100-second recap, at the start of each episode for a lightning fast summary. Let's see the 100-second recap. We began this series by discussing how computers are only capable of understanding machine language, which is inherently difficult for humans to read and write because of zeros and ones, of course. To simplify the process of communicating instructions to a computer, high-level programming languages were developed along with tools like compilers and interpreters to translate these instructions into machine code. Java is one such high-level language. We then began by covering alphabets of Java, also known as the character set, specifically focusing on the Unicode UTF-16 character set supported by the Java programming language. From there, we moved on to forming more meaningful words using these alphabets like literals or constants, 8 primitive data types, and identifiers like keywords, variables, and named constants. We also learned how to perform different arithmetic, logical, and relational operations on data using these Java operators. The next logical step, just like in any language, is to combine these words like variables, literals, and operators to form complete sentences. In Java, these sentences are called statements, which represent a single unit of execution. And that's a 100-second recap for you. Let's get started. An expression is a construct or a combination of variables, literals, operators, and method calls. Remember these four components, which are constructed according to the syntax of Java programming language and which evaluate to a single value of fixed data type. For example, consider these four combinations. All of them represent expressions in Java. In the first example, 10 and 5 are integer literals, which are combined using an addition operator. In the second example, var1 and var2 are variables combined using the minus operator. In the third example, var1 is a variable and 15 is an integer literal, and both are combined using the greater than relational operator. And finally, in the last example, we have a method call where the method named calculateSum is called, and the result which it returns is multiplied with 0.5, which is also a double literal. When I say double literal, it implies a literal of data type double. All these examples show how different combinations of variables, literals, operators, and method calls can form an expression. But does that mean you can form any such random combination of variables, literals, and operators, and that will create an expression for you? No. So let's understand why that is the case. In the previous episode, we discussed that Java is a statically typed language, meaning that every variable, constant, or literal we declare must have a specific data type associated with it, such as int, float, long, double, etc. On that note, Java is also a type-safe language. Type safety ensures that the compiler validates the data types of variables and literals while compiling or running a program and throws an error if you attempt to assign an incorrect type to a variable in any operation. For example, consider the operation of binary addition using the plus operator. When creating an expression with plus operator, there are two important syntax rules you need to keep in mind. First, the plus operator is a binary operator, meaning it requires two operands. Second, both operands must be of either integral or floating point data type. It cannot be of a Boolean type or any other reference type. We covered that in the last episode, so check that out. Now, let's apply these rules to determine if an expression is valid or invalid. Consider the first expression, for instance. Here, we are trying to add 2 and 5, both of which are literals of int data type. This expression satisfies both the conditions for the binary addition operator. The correct number of operands are present and valid data types are there. Therefore, this is a valid expression. Consider the second expression. Here we are trying to add 2.0 and 5.2, both of which are literals of double data type. Again, this expression meets all the conditions, therefore it is also valid. In the third expression, we are trying to add 2 and true, where 2 is an integer literal and true is a Boolean literal. Now remember that plus operator requires both of the operands to be of either integer or floating point data type. So this expression is completely invalid as it violates the syntax of Java programming language. In the last expression, we have an integer literal 5 followed by a plus operator. This is definitely an invalid expression because a plus operator expects 2 operands, but here we have only 1. So that will not suffice. Operations which are not supported leads to the formation of invalid expression, which ultimately results in compile time or runtime errors. Now that we have covered the syntax and validity of an expression, let's dive into how an expression is evaluated in Java. In this episode, for the sake of our understanding how expressions are evaluated, we have categorized expressions into some groups. The method I will share for solving an expression is unique and simplifies the concept of precedence, associativity, and type conversion. Let's look into that method. An expression that contains a single operator and 2 operands of the same data type is what we will refer as a simple expression in this episode. Let's examine these 4 expressions again. In the first one, 10 and 5 are literals of type int. In the second expression, var1 and var2 are variables of type int as well. In the third case, var1 is a variable of type int and 15 is a literal of type int. And in the last expression, calculate sum returns a value of type double and 0.5 is also a literal of type double. To evaluate these expressions means finding a single value of a fixed data type that the expression will return. So we are going by the definitions of expression. If you are performing operations on the same data type, the final result will also be in that data type only. So for the first expression, 10 plus 5 returns 15, which is of type int, because both 10 and 5 were also of data type int. In the second case, var1 minus var2, which simplifies to 60 minus 30, returns 30 of type int. Similarly, var1 greater than 15, which simplifies to 60 greater than 15, evaluates to true, which is a Boolean literal. And in the last case, calculate sum returns 10.0, which is multiplied by 0.5 to give the result of 5.0 of type double. Evaluating expression simply means performing the operations and arriving at a final result. This process is straightforward for simple expressions. But what happens when multiple operators and multiple operands with different data types are involved in an expression? Will the process be that easy? Let's explore compound expressions in Java programming language. An expression which consists of more than one operator and 2 operands will be called as a compound expression in this episode. Consider the compound expression 30 plus 20 multiplied by 100. There are 2 ways to solve this. First, we can perform the addition operation, that is 30 plus 20, which gives us 50, and then perform the multiplication operation with 100, which gives us 5000 as the final result. In the second case, we perform the multiplication operation first, that is 20 multiplied by 100, which gives us 2000, and after that perform the addition operation, which gives us 2030 as the final result. See the difference between both the result? The order in which you apply the operators can produce different results from an expression. In this example, the result of 2030 follows the correct order of operations as defined by the Java programming language, whereas 5000 is an invalid result. Let's look at another example. 25 divided by 10 multiplied by 30. In the first case, all three values 25, 10, and 30 are literals of data type int. Whereas in the second case, 25 and 30 are literals of type int, but 10.0 is of data type double. We will solve both of these expressions in the exact same way that Java prefers, that is division first followed by the multiplication operation. In the first case, 25 divided by 10 gives 2. We will explain why it's not 2.5 later in this episode, and then multiply it by 30 to give a final result of 60. In the second case, 25 divided by 10.0 returns a 2.5, and multiplying that by 30 gives us a final result of 75.0. Notice the difference. The data type of operands, whether they are literals, variables, or method calls, can also change the final outcome of an expression. From these two examples, we can conclude that evaluating a compound expression requires understanding both the order of operators and the data type of the operands. To simplify the evaluation of expression, we have divided this episode into 4 key segments. First, we will cover expressions with the same data type for all the operands, but different operators, introducing the concept of precedence. In the second segment, we will focus on expressions with same data type for operands and also the same type of operators, explaining the concept of associativity. Next, we will explore with different data types for operands but the same operators, introducing type conversions and casting. Finally, we will discuss how to solve any such miscellaneous general compound expression. So these are all 4 possible combinations, and we have divided it into 4 segments based on that reasoning. In this video, which is part 1 of episode 3, we will cover the first 2 segments on precedence and associativity. The next 2 segments focusing on type conversions, context, and the evaluation of miscellaneous compound expressions will be covered in part 2 of episode 3, which will be released later next week. Operator precedence in Java determines the order in which operators in an expression are evaluated when multiple such operators are involved. In this section, we will focus on expressions where all operands are of the same data type, but different operators are being used. For instance, take this expression. It contains operators like addition, subtraction, multiplication, and division. However, the operands 55, 2, 20, 10, 4, and 60 are all literals of data type int. Now, let's first understand the problem that we might face when we don't define any precedence at all. Let's approach this expression in 2 different ways. First, using a random method where we select any operator at will, and second, the Java defined method where operator precedence is followed. We will begin with the random method first. First, we decide to perform the addition operation. So 55 plus 2 gives 57. Next, we choose the subtraction operation. So 57 minus 20 gives 37. Then we choose the division operation. So 37 by 10 gives 3. Then multiplication happens. So 3 multiplied by 4 gives us 12. And lastly, we have addition operation. So 12 plus 60 gives us a final result of 72 with a data type of int, because every operand was of the int data type. So the final result is also of the same data type. Now, let's consider the Java way. For this expression, division will be chosen first. So 20 by 10 gives 2, followed by multiplication. So 2 multiplied by 4 gives 8, followed by addition. So 55 plus 2, which returns 57, followed by subtraction, which is 57 minus 8, that returns 49. And lastly, addition. So 49 plus 60, which returns final answer as 109 of the int data type. Notice the difference between the two results. The order in which operations are performed changes the results. Therefore, a standardized set of rules is needed to resolve such ambiguities, which is precisely what operator precedence in Java does. In the hierarchy of operator, the highest precedence belong to parentheses or brackets, which should always be evaluated first. Following this, in decreasing order, are the postfix increment and decrement operators. Next comes unary operators such as plus, minus, prefix increment, decrement, logical not, bitwise not. After that is the casting operator, which will be introduced later in this episode, followed by multiplication, division, and modulo. Addition and subtraction comes next, followed by shift operators, relational operators, equality operators, bitwise and, XOR, or, logical and, or, then the ternary operator, and finally the assignment operators, which have the lowest precedence. Note that operators which are on the same level have equal precedence. For example, multiplication, division, and modulo share the same priority. To resolve ties amongst them, we use associativity, which will be covered in the next segment of this episode. So let's look at some examples. To solve any expression, follow these two steps. Step 1, bracketization. That is, place brackets around the operator and its operand, which has the highest precedence, and continue adding brackets in decreasing order of precedence until all the ambiguity is removed. In this case, parenthesis has the highest precedence. The expression inside the parenthesis is still unclear because it's uncertain whether subtraction or multiplication happens first. So it's ambiguous. From the precedence chart, we see multiplication takes priority over subtraction. So we place green brackets around the multiplication operator. Next, between multiplication and addition, multiplication has the highest precedence. So we place blue brackets around it, and that completes the step 1. So we have removed all the ambiguity and we now know how to perform the operations. The step 2 is to solve the brackets. Parentheses or brackets can be nested, in which case the expression with the innermost parenthesis is solved first, and then we go in the outward direction. So first solve the innermost bracket, that is 6 multiplied by 5, which gives 30, followed by yellow brackets, that is 90 minus 30, which gives 60, followed by the outermost blue brackets, that is 5 multiplied by 60, which gives 300. And at last, remaining addition operation is performed between 10 and 300, which returns 310 with int data type as the final answer. Let's look at another example. Consider this expression with various operators including arithmetic, relational, logical operators. Let's evaluate it. According to the precedence chart, division and multiplication have the highest precedence amongst these operators. So we place blue brackets around them. Next, the addition operation takes place. Let's put green brackets around it. Next is the greater than relational operator. So let's put pink brackets around it. Next is the equality relational operator. So let's put red brackets around it. And finally, the lowest precedence belongs to the logical AND operator. Note that all of these rules apply to variables and method calls within expressions as well. But for simplicity, we are considering only literals in an expression. Now, to solve the expression, start from the innermost brackets and move towards the outermost brackets. First, solve the blue brackets. 5 multiplied 3 is 15 and 8 by 4 is 2. You can solve similar color brackets in parallel. Next, solve the green brackets. 10 plus 15 returns 25. Then solve the pink brackets. 25 greater than 12 returns true. Next, the red brackets. 2 equals 2 gives true. And in the end, logical AND operator is executed, which results in true literal of Boolean data type. Now that we understand precedence with the help of these examples, let's move to our next segment, associativity of operators in Java. When an expression has two or more operators with the same precedence or priority, the order in which they are bracketed is determined by the rule of associativity in Java. Consider this expression. All the operands are literals of data type int, and all the operators are of same precedence or priority. Let's first understand the problem that we might face when we don't define any associativity in Java. We will solve this expression in two ways. First, using a random method where we choose operators arbitrarily, and second, following Java's rules of operator associativity. Let's begin with the random method. Let's start with 3 multiply 10. It returns 30. Then we perform 4 multiply 30, which gives 120. Then we perform 72 by 2, which gives 36. I'm choosing operators randomly. Then we perform 36 by 3, which gives 12. And at the end, 12 by 120, which returns a value of 0. Lol. Now, let's consider the Java way. In Java, we go from left to right. First, 72 by 2 happens, which gives 36. Next, 36 by 3 returns 12. Then we perform 12 by 4, which returns 3. Then we perform 3 multiplied 3, which gives 9. And finally, 9 is multiplied by 10, which gives final answer as 90. See the difference between the both values? A standardized set of rules to resolve such ambiguities in equal precedence expression is precisely what operator associativity in Java does. All the operators in Java are left to right associative except the unary, casting, ternary, and assignment operators, which are left to right associative. Left to right associativity means when two or more operators with same precedence appear in an expression, they will be evaluated or bracketed from left to right and vice versa for right to left associativity. Let's look at some examples. Consider this expression. Among all the operators here, we know that division, multiplication, and modulo have the highest precedence. However, they all share equal precedence. To resolve this tie and eliminate any ambiguity, the operators will be grouped from left to right based on their associativity. So first, division is performed. So we place blue brackets around it. Next, multiply is executed. So we place green brackets around it. Then modulo is carried out, so we place red brackets around it. After that, multiply is performed again, so we place it in blue brackets. And finally, the addition operation, which has the lowest precedence, will be evaluated at the end. The evaluation is simple now. We start from the innermost blue brackets, solve them, then move outwards and evaluate the green brackets, and in the end, evaluate the print brackets. You can pause the video and try it out yourself, or you can let this animation play. After this, at the end, we get our final result as 25, which is of data type int. Pretty simple, right? In this expression, all the operators are of the same type, which are assignment operators. To resolve the tie between them, we check their associativity and find that they follow right to left associativity. So we first place blue brackets around the rightmost assignment operator, then follow with green and pink brackets as we move towards the left. The evaluation is straightforward and ultimately all variables end up being equal to 10. That's pretty easy, right? And that was an elaborate discussion on expression evaluation using precedence and associativity in Java. To summarize, expressions are valid combinations of variables, operators, and method calls that always return a single value of a specific data type. Evaluating expressions in Java involves solving operations step by step to reach a final value of a fixed data type. To standardize the order of operator evaluation, Java introduces the concept of precedence and associativity. Precedence determines which operator in an expression will be performed first, but when operators have the same precedence, associativity comes to rescue and it is used to resolve conflicts and determine the order of execution, removing any ambiguity that is present inside the expression. And that's it for this episode. In part 2 of episode 3, we will talk about how you can evaluate your expression when multiple operands of different data types are involved within an expression using the concepts of data type conversions and context in Java programming language. The next episode will dive deeper into the handling of data types in Java. So thanks again for watching. If you enjoyed the animations and the content, please consider giving this episode a like. It really helps the channel grow. And if you want to see more content like this, don't forget to hit that subscribe button and ring the notification bell so you never miss out on an update.